It's time to introduce our plenary speakers for today. The first speaker is Donald Wyse. Donald Wyse is a professor in the Department of Agronomy and Plant Genetics at the University of Minnesota St. Paul, where he teaches and conducts research on invasive plant management, cropping system development, plant breeding, and new crop development. His research efforts focus on the development of perennial cropping systems, cover crop systems, prairie polycultures, and their impact on soil and water quality. Dr. Wyse was the founding director of the Minnesota Institute for Sustainable Agriculture, initiated the development of the Regional Sustainable Development Partnerships, and was founding director of the Midwestern Cover Crop Council, and currently serves as co-director of the Center for Integrated Natural Resources and Agricultural Management. Recent activities of the center have led to the development of the Mississippi River Greenland Blue Water Initiative, GLBW, which is a consortium of universities, state and federal agencies, and NGOs that have organized efforts to add perennial and winter annual crops to agricultural landscapes that will improve soil health and water quality in the Mississippi River and Great Lakes Basin. Dr. Wyse organized and now leads the Forever Green initiative that is developing new winter and annual perennial crops that can be produced by farmers to provide ecosystem services and new economic opportunities. The second speaker is Nick Jordan. Nick Jordan is a professor of agronomy and plant genetics at the University of Minnesota and a resident fellow at the university's Institute of the Environment. He received his PhD from Duke in 1986 and was appointed professor in 1994. His areas of interest are agroecology, weed ecology and management, and diversification. His research program in agricultural ecology addresses the use of biological diversity to improve on-farm productivity and resource efficiency while reducing harmful environmental effects of agroecosystems. Research, instruction, and many service and outreach activities are integrated around this theme.
Well, thank you very much. Thank you for that extended introduction. And I'm glad to see all of you here so early in the morning, and glad to have the opportunity, invitation to come in and present the Forever Green initiative to all of you. The Forever Green initiative, to move into it really fast, the goal of the Forever Green initiative is to develop new perennial and winter annual crops and cropping systems that produce new economic opportunities for farmers and the entire food and agricultural system, and also produce ecosystem services. So it's an economic-driven opportunity to produce ecosystem services with that economic pull, right? Farmers have the opportunity to increase their profitability and at the same time produce those ecosystems that result in soil health, cycling of nutrients, improvement of water quality, not only here in Minnesota because of the other big initiatives that Greenlands Blue Waters, extending these outcomes across the Mississippi and Great Lakes basins. This isn't new, this idea of producing new crops at the University of Minnesota. As you go by the St. Paul campus, you look across that research land, every crop that's currently on the landscape in Minnesota came from those fields. All of them, except for sugar beets. All the other crops originated with taxpayer dollars. The genetics, the breeding work, agronomics initially was done on those fields to produce those new crops. We are now just focusing on the development of a new set of those crops, winter annuals and perennials. Why? Basically designed to fill the brown period that occurs on the Midwestern landscape in the fall and in the spring. But fill it with crops that provide new economic opportunities for the farmers. That's basically the background for this initiative. So those crops that were produced on those fields went out across the landscape starting back in, the early 1900s. And as the farmers utilized those crops, they put them into pretty diversified landscape systems. It wasn't the original prairie, right? But there was still a wide range of diversity in that system. This is from a general field in the Midwest in 1941. Look at the perennials, the pasture, grasses, alfalfa in that system. Look at soybeans. Do you see that little gray spot up there? Very few acres across the landscape in 1941. That's when we started breeding soybeans at the University of Minnesota. There's been 3 soybean breeders, and look what happened. By 1976, we were well on our way to having that 2-crop system on the landscape throughout the entire Midwest. What happened? A lot of you in the room know what happened. Livestock was removed from a high percentage of the farms, producing grains, feed grains that went to feedlots to feed the livestock. That separation. So basically, we now, starting in the 70s, have a 2-crop system, highly productive. Highly productive. What's the issue? They're all winter annuals and they're summer annuals, and they're only on the landscape for about 3 months. Rest of the time, no living plants on that landscape. So now we're looking at about 60 to 70% of the agricultural land in Minnesota and throughout the region, throughout the Midwest, covered with these 2 crops. Nothing wrong with those crops. Highly productive, but they're only on the landscape for a short period of time. Not protecting that soil, the water, cycling nutrients for really a short period of time. So this low crop diversity results in the limited availability of new food and feed ingredients, restricted development of new food and feed marketing opportunities for the food and agriculture industry, and we've lost most of the ecosystem services. We've lost those ecosystem services. The question is, can we develop an agriculture system that is highly productive, more productive than what we currently have, and at the same time produce those ecosystem services? That, for me, is the grand challenge for all of us, and especially at the land-grant university here in Minnesota, the University of Minnesota. The consequences of that loss, we talk about this all the time. I even hate to put up the soil erosion slides anymore. We've seen those slides forever and ever and ever. And if you drove around the Midwest this summer, you were really seeing them again, right? Downstream, impact in the Gulf of Mexico, but also right here at home, impact on the quality of our drinking water, both for homeowners as well as rural communities as a whole. Why does this happen? This goes back to what I've been just trying to set up. Midwestern agriculture is based on these summer annuals that do not provide a continuous living landscape to protect the soil and water base. It shows up in this slide, basically laying it out in terms of what that looks like. This is looking at solar radiation precipitation over time. And look at what we have in the landscape. This is a satellite shot of chlorophyll in the landscape. Look at Minnesota in April. We're pretty brown. But so is a large portion of the entire corn belt. In May, we're still brown. When does it start to cover? It's about June 15th in most years. So from that whole period of time, we are not picking up water. We are not utilizing nitrogen and other nutrients in that system. And nitrogen certainly is available to flow through that system. We look really good in July. Really nice green cover across the entire Midwest. That's July. This is October. Now count the months. July, August through September. That's just 3 months that we actually have living plants on that landscape to hold the soil, to keep the nitrate nitrogen in place, and to utilize water in place, right? And we talk about developing efficient systems. That's really what we're talking about. Efficient harvesting solar radiation, using nutrients that are in the soil, and using water in place, right? This system cannot do that. So this is the outline of what's currently on the landscape. In the spring and in the fall, it's susceptible for nitrate movement, soil erosion. What we're trying to try and do is move new crops into that system, that fill that red period, in reality, the brown period. So we've all seen this slide before, looking at the amount of nitrate nitrogen that flows through the system. Some debate whether it's 250 million pounds of nitrogen per year or even more, but it's substantial. And it's not just a pollutant. It's worth 50 cents a pound to the farmer. Pollutant one issue, the efficiency of the system and keeping nitrogen in place so it can be used by the crops is a whole other issue, and a very important issue to farmers. So, again, where is most of the nitrogen coming from? 75% of it is coming from that disturbed agricultural system that is being planted to those summer annuals. When that soil is bare, we receive a lot of rainfall. Right? The plants aren't there, the water isn't being used, it moves through the system and carrying nitrate nitrogen with it, as well as sediment, loading in sediment. We all know that a large portion of the Midwest has tile lines in it. And you look at tile line flow, when do you get most of the tile line flow? When those crops are not there. Nitrate nitrogen moving with it into the tile line, into surface water. A lot of you know the author of this work, Giles Randall, a world-class soil scientist. Spent his career at Wyse, Minnesota. Going back and looking at some of his research when I was working with him back in the 90s, this is a piece of research that caught my attention. And would have to argue that this was probably what got me to think about creating the Forever Green Initiative. If you look at nitrogen loss in terms of pounds per acre, with continuous corn, soybean rotation, the soybean corn rotation, basically based on the tile drainage in terms of acre inches. When you look at the corn and soybean rotation, the loss ranged from 5 to 80, depending on the amount of water that was moving through that system. But what captured my attention was he also had treatments in there of alfalfa and a mixture of perennial grasses. The loss across that continuum went to 2. And what I always like to tell people is the Forever Green initiative is figuring out how we get to 2, but still maintain the profitability of the agricultural system. And to me, that is the other part of the grand challenge. I want Minnesota landscapes to release 2 pounds of nitrogen rather than 20 to 80, and make it more profitable for the farmer. That is the grand challenge. And a lot of you have participated in making these predictions. A lot of you sitting in this room, trying to get that to that 40% reduction in nitrate loading. And this is kind of the general thought. There are a number of tools to get us to that 90%, that's 40% reduction in nitrate loading, increasing the efficiency of fertilizer through precision agriculture techniques, modifying our tile line management systems. But I think there's this general agreement that if we want to move to that 40 to 50% reduction, we need to have some new plant materials as part of the agricultural system, as part of that agricultural landscape. In other words, moving the forever green crops in spring and in the fall and winter to cover that brown period that I showed you earlier. But don't just fill it with any plant. Just fill it with plants that have and can provide new economic opportunities for farmers to make that change. All right? So this would represent what we would consider to be the winter annual component. Plant it in the fall after the main crop comes off, provides that winter cover. It grows in the spring. But if it's a perennial like Kernza that we will talk about a little bit later on, it would be a complete bell-shaped curve, right? A continuous living cover. So the approach that I'm going to talk to you about today is really 2. Putting perennial plants on the landscape that give you that continuous living cover, but also then to create it with an overlap of winter annuals and summer annuals to provide that living cover over the landscape. But again, designed to do what? Fill the brown period. Create a more efficient agricultural system. So here we go. Produce new food ingredients, new feed products, new economic opportunities, and all of us sitting in this room know that rural America needs new economic opportunity. We think through the development of some of these new crops, it will create new enterprises, and Nick will talk a little bit more about that here in a few minutes. But getting both, new economic opportunities as well as the production of ecosystem services, including improving water quality and soil health. So here we go. New unique food and feed ingredients coming from the new crops, oils, fiber, protein, and phytonutrients, just as an example. So we want high-value ingredients, provides opportunity for green marketing for a wide range of companies, innovative new food products such as high-quality proteins for the emerging high-protein diet, right? Whole new marketing, whole new opportunity that can be developed from these new crops. And again, for me as a farm kid, focusing on how do we enhance, diversify farmers' income. So when it comes to environmental services, these are the things we're talking about. We now have a major focus on soil health. In my opinion, we will never get there unless we have roots in the soil for a longer period of time. It opens up the whole opportunity to sequester carbon, and most of our systems don't do that today. Production of clean water, nutrient management, cycling of nutrients within the agricultural system, pollinator habitat, and I mentioned carbon sequestration earlier, and the protection of soil, protection of that natural resource base. So here we go. Focus on the development of winter annuals and perennial crops that protect the land off-season, increasing the profitability of the food and agricultural systems. And I don't just mean for farmers, all the way through the supply chain to the food and feed industry. So, sounds good, right? How in the heck do you do it? So if you go back to the soybean industry, how did that start? It started with plant breeding. And now we have new tools in genomics that allow us to develop some of these new crops much faster than what soybeans were developed, right? Some of you in the room, do you remember what the initial yields of soybeans that were released from the university were? About 18, 19 bushel, maybe 20. What are the soybean yields today? 80, 60 to 80 bushel. Where did that come from? Plant breeding and genetics provided most of that input. So every crop I'm going to describe to you in the Forever Green Initiative, the primary focus of the work is on the development of high-quality germplasm for these new crops. But once you have it, you also have to develop the agronomics. We need the food scientists involved in developing the new products with industry. And then Nick will talk about the commercialization and supply chain development using some of our crops that are now being rolled out as the examples. So here are the crops that are currently under development in the Forever Green Initiative. They break out into three groups. The perennial crops, and the one you've heard the most about, obviously, is intermediate wheatgrass, kernza, but also perennial sunflower, and a series of others that are also under development. And then the winter annuals that can be used in the current corn and soybean rotation, being pennycress, camelina, winter barley, and then the hairy vetch. And then the native woodies, the one that is receiving a lot of attention is hazelnut. But these are the ones that are currently under development in the program. How extensive is it? There are 55 people at the University of Minnesota that are actively funded to work on these crops. It's a large group of faculty, graduate students, postdocs, and undergraduates that are engaged actively in the development of these new crops. Now I'm going to give you two examples. I'm going to pick one out of the perennial group, and then I'll pick one or two out of the winter annual grouping of crops. So intermediate wheatgrass is being domesticated. The trade name is kernza, but before it gets that name, it's being produced as intermediate wheatgrass. It has a lot of opportunities in the marketplace. We always put beer first. Other food crops, biomass, and is also a crop that can be grazed. It was introduced in the United States 125 years ago as a forage crop from Eurasia, the Caucasus regions. So it's been in the United States for a long period of time. We are just domesticating it as a perennial grain, right? This is why we're interested in it, and this is one of the reasons we're interested in the context of wellhead protection. It has very deep roots. The plant to the left in each one is winter wheat. That is a difference in root development between Kernza and winter wheat. The question is, can it pull nitrogen up that's already down? And we now have evidence that no nitrogen goes through that system. It's a 2, if you remember earlier. This meets that goal of 2 pounds of nitrogen moving through the system. So here we go. Why did we start with it? It has already pretty large seeds. It has large biomass. The other key issue, it has a lot of disease resistance. As a matter of fact, it's crossed with annual wheat to move disease resistance for intermediate wheatgrass into wheat, right? But as most of you know, that if you put any crop on a few million acres, something bad will find it, right? So we're well aware that we're starting in a good place, but it's still going to maintain a breeding effort over time to make sure that we stay on top of these disease issues. It can also be grazed. It's in grazing trials at Morris in the organic dairy to look at as a crop that is dual purpose. You can graze it, you can harvest it for forage, and also harvest it for a grain. So that's the blend of economic opportunity that it presents. And it also has favorable end use. The grain has good flavor. As you know, it's been served at the State Fair for a few years now and has been received very well in a BLT sold by Farmers Union, made by the Birchwood Cafe. So it has a unique flavor. The protein content is about 24%. It's a high protein grain. Wheat is in the range of 12 to 14. So basically, just to get the idea, we're not making broad crosses. We are basically just crossing within the species, identifying domestication traits. So it's direct domestication. There's no genetically engineering involved in the development of this new grain. So this is a nursery on the St. Paul campus, a nursery just like you would see in the development of any of the other crops. So the nursery making the selections of crosses and then the variety evaluations. And this is the big deal. As a result of 8 years of research, we've released the first variety, Min Clearwater. Remember, 2 pounds, maintaining the nitrogen in place, not allowing anything to move through it. It's shatter resistant, it doesn't lodge, has very excellent traits for the first variety. Are we going to stop? No. We need to continue to increase the yield of this species, but the breeders, Jim Anderson, has made great progress. And the reason we can make great progress is that we can now sequence the genome of these crops and go in and find the mutations that we need to domesticate the crop. That's why the domestication of these crops is now possible in a shorter period of time. Rather than 100 years, getting down in the range of 10, right? Using these new technologies. And this is not genetic engineering. This is basically finding the mutants that are already there, making the crosses to advance the domestication traits. So the uses, the work that's going on, nitrogen rates, row spacing, harvesting times, grazing, all of these agronomic things have to be done with each variety that's released. And this is what I wanted to show you. Water Quality Conference. Look at the bottom line. This is the nitrogen concentration below this stand of Kernza. It's 2. It's low. Nothing goes through it. It's even better than switchgrass in comparison to the corn system, right? So this is the model. This is really what we want to accomplish. We're meeting its environmental goals. Can we now continue to increase the yield of this crop to make it profitable for both General Mills and the farmer? And that's what Nick will talk about. So here we go. Evaluation of wheatgrass for food products. So there's a wide range of food science research going on. Food products in the marketplace already. And then we'll switch to the last one. I'm almost on time. So this is the example of the winter annual. So there's 2 that are moving along really pretty fast. Field pennycress and camelina. Both very winter hardy winter annuals, and you all know, if you're from Minnesota, we're really limited in what plants we can put in the fall and expect to survive. These are 2 that look very good in terms of winter hardiness. So these are designed to be planted in the fall, established in the fall, grow in the spring, and be harvested within the corn and soybean rotation. Doesn't displace corn and soybeans. It fills the brown with new economic opportunity for the farmer. That's the model. So it's a high oil. A lot of you know it's a weed, right? We are domesticating a weed. Basically taking a weedy species and domesticating it. It has high oil content, high protein content, and has some unique proteins as part of that seed. So, extremely cold hardy, rapid seed maturity, so it produces seed and you can harvest it and still grow corn and soybeans. High oil content, fits into a double crop, relay cropping system, and it's set up that we can make very rapid genetic improvements, and I'd be happy to talk to you about that. And that'd be after the presentation, and we'll take the time to do it now. So this is the game. Starting up there on your upper right-hand side, planting the camelina or pennycress into corn, it overwinters, and then we come in and plant soybeans, no-till, directly into the camelina or pennycress. They grow together, and we harvest the pennycress or camelina over the top, releasing the soybeans. In a double crop or relays, this would be a relay system. Get the idea, that overlap of the green, right? In other words, it's a unique type of cover crop. A cover crop that has economic value. So this is the game. Again, you see it in the background. See, June 16th, it's ready to harvest, right? So you've had that cover all the entire spring. Look at May 31st. It matures very, very fast. And this shows you how in the camelina, the soybeans would be growing with the camelina, and the camelina would also then be harvested over the top. Again, this is what it looks like, a harvester going across, harvesting the pennycress or camelina, leaving the soybeans then that will grow for the rest of the growing season. Okay, let's go back to 2. These systems, If you look at the spring and fall, if you look at winter rye, pennycress, and camelina, these two crops are as efficient as the standard winter rye, except they provide new economic opportunities for the farmer. So it drops the amount of nitrate nitrogen moving through the system by about 90%. So within this species, we have tremendous capacity to grow these new crops. Pennycress for biofuels, bioplastic, cooking oil, as well as the source of protein. So I'll stop with this slide. Basically looking at protein ingredients, oil, and fiber from this new winter annual crop or set of winter annual crops. So I'll stop there and set it up for Nick. But the underlying principle I hope you're picking is we're not, as a farmer myself over the last number of years in northwestern Ohio, looking at the options that I had to help protect the water supply that was going in to the Maumee River into Lake Erie and impacting Toledo. I was one of those farmers in that valley, trying to figure out how to move something on that landscape that would protect that land, hold that nitrate nitrogen in place, and still maintain a profitable system was a struggle. What we're trying to do through this program is to give farmers more tools to be more effective in protecting that landscape through a new economic pull to make that happen. With that, thank you very much.
Well, good morning. I'm so glad to see you out there and so grateful for the opportunity to paint this picture of this Forever Green work that Don has started. So the title of my talk is an annoying question that I like to ask my advisees at the University of Minnesota. They usually shrug and sort of frown at me and say, well, where do you want to be in 5 years? And I think it behooves us in a project of the sort that Don has been talking to you to really think about what is the way forward. And I also had the opportunity to look at the questions that have been contributed in the pigeonholes so far. And what I saw was lots of interest in, okay, there's a lot of moving parts here. There's a lot of details that need to be thought through, and what do you guys really think about all of that? So I'm going to try to speak to those things. I want to take a few minutes to tell you how it is that we hope to get towards our first place we want to be in 5 years, which is to be in a phase of rapid expansion of continuous living cover, this ideal of having living roots in the soil in our agricultural landscape. We want to be in a phase of rapid expansion. The other thing that we hope to be doing is to begin to be creating climate solutions that we build on a platform of continuous living cover. We see a very large opportunity to gain ground in addressing the relationship between Midwest agriculture and climate change through this goal of continuous living cover. But first things first, let's talk about this business of rapid expansion. So let's just talk a little bit about what it takes to realize the potential of what Don Wyse has just been explaining to you guys. And in other words, what does it take to actually commercialize a crop like pennycress or intermediate wheatgrass? So clearly you have to have the crops that function decently. Clearly you have to have a supply chain. And a supply chain starts with production, obviously, and it ends with the end-use markets that put products from these crops into the hands of people who want to buy them. And you also need markets that fundamentally make a profit. So the whole supply chain has to make a profit. And so that means farmers have to make a profit. That means rural communities have to benefit. That means our agricultural economy in the Midwest has to benefit. Now, to achieve those three things, which are all significant undertakings, obviously you need to know a bunch of stuff. A lot of knowledge and innovation is needed. Don showed you this same image that points out that there's a wide range of things we have to understand. And it's critical to realize a couple things. So first of all, it's absolutely necessary to understand all of these things. So these are each aspect of an effective system that gets continuous living cover crops out into the landscape at scale is necessary. You have to have the good plants, you have to know how to grow them, so on and so forth. And furthermore, there's risk associated. Research and development is expensive. So there's a big challenge here. And the only thing that makes any kind of sense is to be very serious about coordination, working together across the parts of this sort of knowledge construction project here that are best done by the academic world, parts that are best done by other creators of knowledge. And by being smart together, there is the opportunity to make sure that nobody gets too far out in front of their skis in any of these areas. So that's a very important part of our strategy. And we are trying to get ourselves organized. There we go. In research groups that are public-private partnerships that address all of the different dimensions that are listed over there on the left of the slide. So that's how we're trying to organize the knowledge and innovation that's needed. But a critical thing to sort of harness is that the world needs to see things happening in practice, on the ground, and not just being talked about as possibilities that we are studying, but we need to know more about. That's what there's so many things like that, right? And that doesn't build the energy and enthusiasm that is critical to actually bringing people together, to put their shoulders together to make change happen. So the engine that we are trying to harness and use to drive all this work forward is to actually try to grow the markets and the supply chains, which again start with production and end with consumption, as a way of putting something on the ground that is real and tangible and that will motivate the shared effort needed to move these projects or these crops forward. So I want to tell you a little case study of how we're trying to do this for the crop intermediate wheatgrass, or Kernza. This is one of the crops that Don told you about, of course. And what we're doing to try to integrate the work of a whole bunch of different players, learning to understand my remote here, to move this crop forward and to address all of the kind of details that you guys are raising in your pigeonhole questions. So the situation in 2019 with Kernza is that there's tremendous interest, there's tremendous excitement about the possibility of a perennial grain crop. There are a bunch of significant limiting factors which are listed on the slide. Essentially, there's lots of things that we have to figure out. So it takes that concerted effort of research and development and innovation to move this forward. And one particular interest and particular impetus is the interest in finding new leverage to address water quality issues related to agriculture that we've had very little success on addressing so far in the Midwest. And so we are trying to harness that interest in particular to drive this work forward. So our basic strategy is to create what we think of as clusters of Kernza production. And as I was writing this up, I was reminded of General Mills, which has created the world's first commercial product at large scale, which is a breakfast cereal called Kernza Honey Crunch. And I was sort of thinking, well, Kernza clusters could be their next in their product line. But what we mean by our Kernza cluster is a place where we have geographically concentrated production of Kernza. In other words, a bunch of folks who are growing this. And there's some real value in doing that. So first of all of our partners that are trying to figure out if Kernza will work for them, and so I mean General Mills, I mean agricultural intermediary firms that are sort of like Cargill, such as Pipeline Foods and others. I mean farmers who are interested. I mean local co-ops, agricultural co-ops. Everybody's trying to figure out if Kernza is actually going to work and could be something that could work for them. And you just can't figure that out if you have a farm with some Kernza on it here and a farm with some Kernza on it there. You have to have a cluster to justify the, frankly, trying stuff out in practice and seeing what works that you need to build a supply chain, to try to build a market. So this is the whole point of these clusters of Kernza. And so that's what I mean by incentivizing the interest and the investment of market and supply chain players. That is equally true for those parties who are interested in the environmental benefits. So rural communities that are interested in getting new leverage on drinking water protection, urban communities that are interested in getting new leverage on protection against flooding. All of these folks can't figure out the whole sort of system, infrastructure, economics of subsidizing these environmental benefits unless they have a cluster to work with. So that is the logic of trying to build these clusters. And in particular, it's the way to manage the whole sort of chicken and egg problem that's very critical. So what is that? The most obvious aspect of the chicken and egg problem is that our commercial partners, like General Mills, can't make investments in products, can't make investments in supply chains unless they actually think there's going to be a supply of Kernza, obviously. Farmers will not take the risks of learning how to grow Kernza and fit it into their cropping systems unless somebody's going to buy it. So that's the obvious chicken and egg problem. But that same problem really exists for any participant in a supply chain, including these intermediary firms, including co-ops, including government at all kinds of levels that might invest in these environmental benefits that are public benefits, essentially. So managing that, we think, is best done by, okay, let's plant a reasonable amount of this crop in a place and see what it looks like when we have it there at scale. And very importantly, that feeds back to all of our, all the things we know we need to figure out. We identify the things that are most important, and we show the supporters and sponsors of that kind of research that there's a there, and that this Kernza thing is more than a hypothetical. So that is the whole logic of this Kernza cluster. Another way of saying that is that if we think about all the different components of a supply chain, there are quite a few links in a supply chain. Anybody that is building a supply chain has to invest in that supply chain. It has costs, it has risks. So that has to be shared. That's another critical part of the logic of this. So how are we thinking about actually doing this? A, we need to find places where people are really interested in doing something different in their agriculture, both from the point of view of production agriculture and from the point of view of protecting things like water and biodiversity. We need to bring the folks that are the beneficiaries and the stakeholders, but also the folks that have to bear the costs and risks of starting to work out these new supply chains together to think it all through. We need to plan out we need to plan out sort of experimental pilot scale versions of all the moving parts needed to create these new supply chains. We need to work with our end use markets to figure out under what circumstances they will actually start buying the product. We are doing this in a way that is very participatory, that involves collaborative planning in watersheds, that involves the use of big data, and very exciting new tools for using that to rapidly explore lots of different scenarios for what these clusters can look like, that importantly bring people together from a wide range of sectors and produce designs for clusters. This is an example for a cluster of alfalfa production we're creating. This is the most interesting remote. It sort of sits there for a certain amount of time. So we're moving along with that whole process. We are cautiously ramping up production. We don't want anybody to rush into this. We need to manage these risks, share these risks. Importantly, we need to be learning. So where we are in the Forever Green Initiative is we're starting to create these clusters for a number of the different crops that are kind of the leading edge of our portfolio of crops. And it occurred to us that since we don't really know how to do this, that we had better really think about how do we learn as quickly as possible. How do we maximize learning as we go forward? And it occurred to us that, well, we have this whole sort of batch of these supply chain projects that we're starting out across the landscape, and they have an opportunity to learn together and to become smarter together about how you do this difficult, risky, uncertain work. So what I want to segue to is to describe to you a multi-level partnership that we're trying to develop that we think will be a kind of accelerator of the implementation of continuous living cover. In other words, we believe that it is possible to devise a system that will really accelerate the sort of trial and error process that inevitably we have to go through with all of these crops. And I want to just briefly explain it to you because it's, I think, an interesting example of how, in the face of very complex and challenging efforts to make change in environmental management, how do we think about organizing that so things move a little quicker than they have around all of our complex environmental challenges? So the partnership is about a few key things. One is the idea that to create new systems that are complicated, you just have to build them and see how they work. And you have to learn as fast as you can from that. And you have to have some system that efficiently redirects resources towards what works. Assuming something kind of works, you have to have a way to refocus resources onto those. And you have to take advantage of what people are now calling polycentric governance, which is the idea that to address complicated challenges, you can't do that with top-down governance and management. You can't really do it bottom-up either. You have to have a complementary relationship between the things that top-down does well and the things that bottom-up does well. And so that's kind of symbolized by this multi-level partnership. So let me just tell you a little bit about how we think this can be built. It has 3 different layers and levels: a steering council, something we're calling an agricultural diversification network, and then the crop R&D work. And I want to just tell you a little bit about each of these. So the steering council is intended to be a very high-level group that we can think of as operating at a sort of 30,000-foot level. This is intended to bring together all of the players in both private and public sectors who have an interest in continuous living cover, who have gotten excited about continuous living cover, who have gotten excited about the economic and environmental and social possibilities of expanding continuous living cover. That is a group that has a common interest, but it needs to think strategically and figure out what it wants to do, how it wants to achieve, make progress on its shared interests, and what it wants to invest its considerable resources in. So that's the work of the steering council. We can also think about another level of work that we're calling the Agricultural Diversification Network. This is a level in which all of these on-the-ground, bottom-up efforts to create clusters for continuous living cover crops can learn together and, as it says there, get smarter together about how we do this difficult, uncertain, risky work of getting these crops out onto the landscape. So there's a key interaction here between the steering council, which has high-level strategic goals, which it can see from its 30,000-foot perch, and the insights that the diversification network has as it sits at, let's say, 10,000 feet and looks down at these bottom-up efforts to make things happen on the ground. So, importantly, the network shares what actually works with the steering council. The steering council shares its strategic goals and the resource investments it's prepared to make. And that's an important interchange. We can also think about this sort of engine room of the whole thing, and that is the crop R&D work. So this is where all of those different lines of research and innovation that I mentioned before, spanning crop breeding to infrastructure and policy design, things like that, and also where the on-the-ground work is all happening. And we can think about a very important interaction between the diversification network at 10,000 feet and this crop R&D engine that's more or less on the ground. And again, the idea is that the R&D network shares their experiences on the platform, if you will, of this diversification network, and the diversification network is able then to feed back what is working generally to these particular projects. And so that's a very important feedback as well. So you can see that what we're setting up here is a kind of a bunch of feedback loops by which the steering council that has broad strategic goals, and very importantly, it has considerable resources when you put firms like PepsiCo, General Mills, Cargill, Land O'Lakes, these are all our partners in commercialization, together with the resource of state, federal, local governments, and certainly the philanthropic and advocacy sectors. Those are a lot of resources. And this is a system that allows those players to figure out what are their shared strategic goals and then invest in what works. That's what emerges from the diversification network, and feed that down into the engine room of our work on the ground. So this is a combined top-down, bottom-up system for advancing continuous living cover. And this is what we hope will drive us into this phase of rapid expansion of continuous living cover that we hope to get to in 5 years or so. So let me finish up. I think a new battery would be a great idea for this remote, by the way, guys. The other thing we're hoping for is to be really advancing climate solutions for continuous living cover, from continuous living cover. Let me talk to you briefly what we mean. We think that it is now the time to envision and start actually planning for and piloting the idea that we can build climate resilient food, energy, and water systems on a platform of continuous living cover. And so what we mean by that specifically is that continuous living cover agriculture clearly has potential to make our basic food production quite a bit more climate resilient. We're not there yet. There's a lot of R&D yet to do. But, for example, consider a crop like alfalfa. Alfalfa is much less vulnerable to cool, wet weather than, say, corn is, or soybean. And we have figured out the technology of creating protein that can be directly consumed by humans, much the way that we figured out a technology for extracting proteins from pea that is now being used in a wide variety of consumer products. We can do that with alfalfa. We can make sustainable aquaculture feed for alfalfa. In other words, alfalfa has lots of use beyond dairy. And it's a great example of a way that our food system and how our protein nutrition could be made much more climate resilient than what we have right now. And then clearly we have the ability to withstand the large fluctuations in rainfall events that we appear to be heading towards, if in fact there is climate change in the future, with continuous living cover agriculture across our agricultural landscapes. So we need our food system, we need our water system to be a lot more climate resilient than it is, right? And so we think that continuous living cover and the basic economic drivers that are inherent in that concept has a lot of potential to move us in that direction. We can also talk about climate mitigation. That means addressing the root causes of climate change. So very importantly, we need to limit greenhouse gases from agriculture, right? The food and agriculture sector is about 25% of global emissions. And there are various ways that continuous living cover agriculture does that well. For example, you know that nitrogen fertilizer produces nitrous oxides, which are extremely potent greenhouse gases, and continuous living cover agriculture substantially limits emissions of that potent greenhouse gas. You know that we can store carbon in the massive root systems of Kernza and otherwise. And importantly, and this is a really major opportunity around mitigation, if we can meet our food needs from a more compact footprint from continuous living cover agriculture, and there's good evidence we can, we have plenty of room for renewable energy infrastructure at scale. That is obviously, that infrastructure is expanding rapidly. Witness all the solar we see even in the metro area counties. But it needs to be thought out, it needs to be planful, it needs to be smart, it needs to be integrated into a broader new vision for these climate resilient and climate mitigating landscapes, rural landscapes built on this platform of continuous living cover. And let me just make one final point, and that is that what we need to drive this forward, I think, is something that I think would have very broad social significance, and that is building new rural-urban relationships to deliver these climate solutions. So there's a very important kind of a symbiosis between the rural and the urban that's necessary to achieve the climate solutions that I'm talking about. So the rural needs to step forward and be clearly recognized for what it has to do, and that is to provide these food, water, and energy climate solutions for cities. And cities need to step forward and recognize that they have an enormous dependence on the rural and start recognizing that. So right now, we live in a time when there's great estrangement between rural and urban people in many ways, and this I think is a remarkable opportunity to start healing that. So this, of course, is the city of Cedar Rapids during one of the notorious floods that's occurred in the last 15 years. And the city of Cedar Rapids is a great example of this kind of rural-urban partnership. The city has entered into very direct relationships with a bunch of agricultural watersheds around the theme of, can you folks retain water in your watersheds so we get flooded less often? And that's the sort of thing that I'm talking about. And the last thing I'll say is that, as Don has pointed out and made abundantly clear, there's lots of good things to be done in the here and now by greatly expanding continuous living cover agriculture. So if the climate doesn't change, it might not. It might not change in a way that is as impactful as we fear. We will have no regrets, I think it's fair to say, in investing in continuous living cover right now. So I will leave it at that, and we certainly look forward to hearing your thoughts through this marvelous pigeonhole system. And again, thank you very much for the chance to talk.
Now we're going to go through the question and answer session. Both Don and Nick are available to answer the questions, and hopefully we'll be bringing up the questions shortly so I can read them to you. First question, the highest vote getter, I guess. Are farmers reluctant to changing from their familiar corn-bean rotation, or do you find they are excited to implement winter crops? And whichever one of you wants to answer that question. Would you like to hear it again?
No, it's very. You want to speak to this?
Why don't you go first, young man?
All right. So, well, there is tremendous dissatisfaction, I think it's fair to say, in the upper Midwest with some of the limitations of our agriculture that's based on our summer annual crops, and a tremendous interest in diversification. There's also a very sober awareness of the challenges of making major changes in farming operations. Obviously, farmers are at the very center of that. So there's interest and there is well-warranted caution about the challenges of integrating these continuous living cover crops into our current agriculture. And by the way, our goal is to complement and reinforce all of the good things that we have in our Midwest agriculture with these new crops. So we view these crops as building on the strengths of our current agriculture and addressing some of the limitations.
I would just add to that, we, all of us in this room know all about risk. And if you look at corn and soybeans, the risk of production has been lowered because of the support of us as taxpayers for that system, right? So that is one of the primary factors that has to be taken into consideration. Taking a new risky crop that does not have the support in terms of federal programs, those farmers are not going to take that risk without crop insurance for these new crops. And I would just relate, the reason I'm in the state of Minnesota, I was brought to Minnesota in 1974 to work with the grass seed producers in northern Minnesota to figure out how to get new perennial crops into a high-risk region of Minnesota. Tough to get a crop in Roseau, tough to get it out. So they wanted perennials. So I developed a series of perennial ryegrass lines that have high turf quality. And we were able to get crop insurance for that new crop. But it also, the lines that we produce all carry high premium. The crops produce 1,500 pounds per acre, and the farmers get $1 a pound. Everyone in this room knows you don't have to push those farmers to grow it, right? It's the most profitable crop in that region, but it also then has crop insurance to go along with it. So as I look at all these new crops, and that question is right on the mark, the answer is you're not going to have a flood of farmers moving forward to grow these new crops unless we figure out how to level the playing field, or the banker isn't going to make loans on a high-risk crop. It's not going to happen. So with that for me is the primary issue. How do you lower the risk to those farmers that would love to move to put these new crops in the landscape to produce those ecosystem services, but they can't take that risk unless there's support for them to do so.
Bottom line is that
we're not going to have the new risk management tools, which are basically policies. We're not going to have those until the players responsible for creating those see something on the ground that looks like it's worth bothering to create those risk management tools. So that's the point of the clusters.
what I'm hearing is that farmers are businessmen and they need to make a business decision that makes sense.
Obviously, I mean, that's exactly right. If you want change in the landscape, it has to make economic sense. And that's really, though, what this program is about. It's getting those options out there, but there's a need for policy change to support those new systems as well.
Next question. What can the legislature or state agencies, MDA, MPCA, do to support farmers implementing the forever green crops? If not in a federal farm bill, what about something specific to Minnesota?
Well, the need is to construct an appropriate risk management system or safety net, and that would involve helping take some of the risks of figuring out how to grow the stuff. That would involve coming up with pilot programs to subsidize farmers for the production of environmental benefits, say related to water. And that would involve helping to subsidize the marketing, and that would help underwrite education around both the benefits and the challenges of these crops. And every one of those things is in the works, or I should say happening in the state of Minnesota, which is a tribute to the creativity and leadership of our state. And obviously, those investments could be larger, but we have to show that there's a there in these crops through this cluster approach. So this kind of innovation, this kind of policy innovation, is definitely underway in a bunch of different directions in Minnesota.
Next question. How do the deep roots of the wheatgrass interact with tile lines? Does it need to be planted on fields without tile lines?
We have those studies underway at Wyse. We have curtains are growing on tile lines, and we're using cameras. And after, I guess it's been 5 years, we haven't seen a major, you'll see a root, but we haven't seen this plugging of the tile lines, but we're continuing to evaluate that, obviously.
Next question. Does adding another crop cycle each year increase the farmer's use of fertilizer containing nitrogen?
25 votes. Whoa. What a great system this is.
Well, I can speak to the pennycress and camelina system. In most of the studies that we've done so far, the idea behind that system is to have the pennycress or camelina utilize the nitrogen that's left from the previous crop. But it's also going to be picking up P and K as well, right? And if you're pulling off that seed, you're removing P and K from that landscape, and it could very well increase the need for P and K. But in the context of nitrogen, it appears that it is basically removing the residual nitrogen that's there from the previous crop. But anytime you remove something from that field, you're pulling other nutrients along with it. Yeah.
Just as a follow-up question, does the deep-rooted systems capture what goes past the normal corn and soybean root depth?
Well, that's the study. The studies that are underway now. We have teams that are working on that. It's actually funded by the General Mills Foundation. So we have a team of people that are looking at that entire cycling of nutrients and water within the Kernza system.
But the information that we have now is the answer is absolutely yes. And you guys might remember Don showed a slide that demonstrated that one can apply 60 kilograms per hectare of nitrogen. That's a moderate rate of nitrogen fertilizer to a field of Kernza, and absolutely none of it is found in the water beneath those fields.
That nitrogen.
Two, right? The number 2.
Well, the other piece of information I didn't show, basically what I showed was the appropriate rates for corn and for Kernza. It's about 60 pounds as compared to 130 pounds for corn. But when we put on 120 pounds on the Kernza, it's still 2. Right? Even if you're over-fertilizing, none of that nitrogen has moved through that system over in a 5-year study.
Do agribusinesses support these efforts?
37 votes. Why don't you speak to it? I've already said my piece on that.
Well, I think as time goes along, there will be support across the entire supply chain. As of right now, the primary support is coming from the end users, right? And the reason that support is there is because of the consumer. The consumer is demanding a new set of food, a new set of food products, and the consuming public is very concerned about water, about carbon in the atmosphere, and putting systems in place that produce products that meet that demand by the consumer. I think that in the long run will be the driver of interest in the agribusiness supply chain, right? And all of us in this room, know we have that infrastructure that's on that landscape. Any change, we talk about our farmers interested in changing. Well, yes, over time, I would argue it's the same thing that we can say about agribusiness. In time, if you prove these systems that have value, and there's a place in there for those to make some profit out of that supply chain, I think that support will continue to build over time. For example, we know that a number of the input companies, those that are producing pesticides and the germplasm, companies like Bayer, has invited me to go to Germany and present the Forever Green Initiative, right? Thinking about these new cover crops, how will they fit into agricultural systems of the future? So I think there's a wide range of folks that are looking at what will that agricultural system look like in the future, and there's a number of them are thinking about investing in some of this new germplasm to create this new agricultural systems for the future.
Another good example of that is that a number of firms in agribusiness, broadly speaking, are making major investments in getting into the business of providing farmers with information about how to manage complex, diversified cropping systems. And so we have firms that will identify your, quote, profit zones on your farm where you actually have a good chance of making money growing corn and soybeans, and the places which are likely to be about 20% of the average Midwestern corn and soybean farm where you don't have any chance of making money. And so, great, so now you know where not to grow corn and soybeans, but the problem has been, so what else are you supposed to grow? And that is where continuous living cover crops, that is where the work of Forever Green steps in, obviously. It's providing alternative crops that are suitable to that 20% of the Midwest where it doesn't make sense to grow corn and soybeans. So the business of using big data to manage these more complex, more diversified farming systems is clearly a growth area, but it requires the building blocks of the more complex system. That's what we're trying to put on the table.
Is this question a little bit backwards? Do the agribusinesses drive the use of their products, or is it the farmers' demand that drives the agribusinesses? That's kind of a chicken and egg thing, but if there's more of a demand for the for a different approach, I would think the agribusinesses would react.
Well, I think you're absolutely right. But getting new crops on the landscape, it will not happen unless there's a demand for the products produced from those systems. Right. So that's why, as I look out across the landscape, the human landscape, I think it is the consumer that is going to be the primary driver of what agribusiness does and what that farmer does, right? If there isn't a market, neither one is going to respond. But if there's a market, if there's a market pull, I think all pieces will fall into place. And I think that's really what Nick was trying to explain earlier in these clusters. Let's figure it out. Let's figure out whether there is an interest and a role for that full array of players to participate. We know that there's a strong consumer interest in the products produced from Kernza. It's huge. Can we put a system in place that reduces the risk to the farmer and to General Mills to move that to that demand that's already been created in the marketplace?
That's right. There's push and there's pull. And they have to be, to make a systems change, which is very hard, you have to have both. And that's what we're trying to organize in these clusters.
I think we're running low on time, so is that our last question, or we want one more? We're done. So please join me in thanking Drs. Wyse and Jordan.